Polyamides क्या है कि they have the ester part that is then reacted with the amine part, and you get this linkage in them. Okay, so this is an amide link, and wherever you have this, that is amide linkage, and it can be, as you've seen, this can be natural, this can be man-made. Okay, now how do you get them? Like, how do we make polyamides? There are many different recipes. One recipe is that I can get something that has the amine part and something that has the this carbonyl part. So what I can do is that I can have something. So box is to show कि अच्छा कुछ भी है ये. अब इस box के एक side पे let's suppose COOH है और इस side पे भी COOH है. अब इसको मैं बोलूंगा dicarboxylic. So if I take a dicarboxylic and I react it with diamine, so इसके दोनों sides पे amine है, तो इससे definitely I will get the polyamide. कैसे? The H part and the OH part will react, they will create water, and because it has two amine group on each side and two carboxylic on each side, it will create two water. Okay, and if I have n of these, it will create 2n water. Now the rest of it will be the polymer, जो भी हमारा polymer होगा. Or in this particular case, वो क्या होगा कि H and OH will remove, and this part remove copy join, remember, RCJ. So remove copy join, this part and this part will join together, and we will get the polyamide that we're looking for. Now let's look at another one. What if I have acyl chloride or diacyl chloride? So let's say I have the same thing as carboxylic acid, but just a teeny tiny change. Hydrogen यहाँ पे आ जाता है. So अब क्या होगा? कोई मसला नहीं है. I can still react it with the diamine, but this time my byproduct will change. What do you think? What will be my byproduct? What do you think? It will be HCl, because I'm taking H and I'm taking Cl. I'll get HCl as a byproduct, plus the polyamide. You'll have to excuse me for a bit. There's somebody at the door now. I'm so sorry. Okay, so as you can see here, we can get diacyl, and that will create HCl as our byproduct. Okay, so I have this thing here. Now, what will this do? Is there any other one? Of course, I can have an amino acid. Amino acid में क्या होगा कि मेरे पास एक side पे NH2 part है और एक side पे COOH part है. Of course, there's a bunch of different things in here that we have already talked about. In A levels, we don't represent amino acids as this. What we do is we represent them as carbon with the hydrogen and something on this side. So I can take one amino acid, I can take two, I can take 15 different ones, and I can just join them in a way that I remove H from OH from one side and H from the other side. This will give water as a byproduct, and then I'll get the rest of it. Okay, so I'm able to get that. So that is, amino acids that are able to, that I'm able to react together. Okay, so does that make sense? Any questions on how I can get polyamides? ठीक है, clear है? कोई issue तो नहीं है?
No, sir.
Awesome. अब हम चलते हैं. No, I think this is all. Yeah. So we have amino acids. We also have amino carboxylic acid. Same thing. मतलब अमीनो एसिड और अमीनो कार्बोक्सिलिक एसिड में फर्क ये है कि अमीनो एसिड में यहाँ पे हाइड्रोजन होता है और अमीनो कार्बोक्सिलिक एसिड में यहाँ पे कुछ भी हो सकता है. ठीक है, so I can take those, I can remove water from them. Of course, I'll need concentrated sulfuric acid to do that. I can take an acyl chloride, that will also give me this. If I take carboxylic acid in this is again O-level stuff. Concentrated sulfuric acid is the way to go. All right, so that is how you get polyamides. अब polyamides में हमारे पास कुछ basic वाले हैं. So for example, there is one that is nylon 6,6. अब मैं आपको monomer बताऊंगा. You have to create a repeat in it and you have to tell me what that will be. So one monomer that we have is hexane dioic acid. Okay. And we also have another monomer for this, which is called hexane 1,6-diamine. Okay, hexane dioic acid and hexane 1,6-diamine. First of all, let's try to draw them. So hexane dioic acid kya hoga? You have dicarboxylic group. So I have this on both sides. And because it is hexane dioic acid, that means I have total of 6 carbons. तो बीच में तो CH2 होगा और कितने होंगे 4. क्यों 4? Because the total should be 6. So the total is 6 here. Now I'll react it with hexane 1,6-diamine. So I have now 6 CH2 groups that are joined with NH2 on this side and NH2 on this side. So notice कि मैं जो पहले box बना रहा था, वो box की जगह पे we have definitive structure. Now the reason we call this nylon 6,6 is because इसमें यहाँ पे भी 6 carbon है monomer में और इस monomer में भी 6 carbon है. So that's why it's called nylon 6,6. अच्छा अब ये कैसे बनेगा? Go on, try to draw a repeat unit of this. So here's what we will get. We'll take this thing again, remove copy join. So you have to remove the OH part on both sides, H part on both sides. So जो बचा उसको आपने join कर देना. So remove कर दिया, ठीक है. Copy कर दिया. अब इसको copy करेंगे या दूसरे करेंगे? दूसरे copy करेंगे. Because हमारे पास अभी repeat unit के लिए ये join होना जरूरी है. तो ये मेरा repeat unit बन गया. This is a repeat unit. Now, of course, this repeat unit is made by removing 2 water molecules here. और अगर ये N होंगे तो 2N होगा. And this is my repeat unit. This keeps on repeating every time. We show it through these bonds. So this is a repeat unit. So nylon 6,6 repeat unit. This thing is actually amazing, honestly, because इसको बनाना इतना आसान है. You can make it in a school lab. And it is so strong. It is strong. क्यों होगा? Strong इसलिए होगा क्योंकि एक तो ये जो चीजें हैं इनके बीच में लॉन्ग चेन्स की वजह से वैन डर वाल्स फोर्सेस हैं. इसकी वैन डर वाल्स फोर्स है, इसकी वैन डर वाल्स फोर्स है. एंड देन यहाँ पे हाइड्रोजन बॉन्ड क्रिएट होती है. एक स्ट्रैंड दूसरे स्ट्रैंड के साथ हाइड्रोजन बॉन्ड क्रिएट करता है. ओके, so basically the carbonyl of one and NH of the other chain that creates a hydrogen bond. तो उसकी वजह से multiple bonds हैं, interchain interaction भी हैं, within the chain भी strong bonds हैं. That is why this is a very strong, very versatile, very good fiber. और बिल्कुल silk की तरह का होता है. In fact, lighter than silk भी होता है. Depending on what silk you're talking about, of course, there are silk that are lighter than this one. So where do we use it? We use it to make hosiery. ठीक है. Rayon एक मटेरियल है जो कि हम यूज करते हैं, बट बिकॉज उसमें इतनी इलास्टिसिटी नहीं होती, इसमें काफ़ी इलास्टिसिटी होती है, तो हम इसको यूज़ कर सकते हैं. ओके. एंड उसके अलावा बहुत से मटेरियल जैसे कि जहाँ पे हमें स्ट्रेंथ चाहिए, जैसे सूटकेस बॉडीज जो हैं उनमें, या रोप्स जो क्लाइंबिंग के लिए यूज़ होती हैं, उसमें हम इसको यूज़ करते हैं. देयर इज अनदर वन नायलॉन 6. ठीक है. और वो भी अगेन उसकी ज़्यादा डिटेल में जाने की ऐसा हमें ज़रूरत नहीं है. I'll just tell you what that is. So it has one monomer. So there is CH2, 5 of them joined with COOH on one side and amine group on the other side. So do you think this is a amino carboxylic acid? Or is it amino acid?
Amino carboxylic.
Yes, this is amino carboxylic acid. And this makes nylon 6. Because it has just one monomer, so और उसमें 6 carbon है, तो अब इसको बनाना बहुत ही आसान है. You basically just remove the water in there and remove copy join RCJ. So remove कर लिया, जो बचा उसको copy कर लिया, और ये हमारा repeat unit तैयार है. If you want, you can make another one of this. उनको बस join कर दें और आपका polymer ready. So it's pretty straightforward. That's nylon 6,6. Again, दो मेन चीजें जो इन सारे कंडेंसेशन पॉलीमर्स के बारे में आपको पता होनी चाहिए, वो ये है कि एक तो इनका मेल्टिंग पॉइंट. Again, because if you heat them, they will become more flexible. Any kind of polymer, you heat the molecules gain more kinetic energy, the linkages become weaker, they become more soft, they become more flexible. Okay, they don't have a sharp melting point because of different interactions, because of many different small portions in them, many different repeat units in them, or within the same repeat unit, बहुत से different monomers से बहुत सी different चीजें आती हैं. So there's a lot of variety in there, in the way these things are arranged, in the way these things interact with each other. तो उनमें कोई sharp melting point नहीं होता. They act like mixtures, to be honest. And if you have polar chains, then the strength will be more. If you don't have polar chains, then the strength will be less. So PVC may nylon, as you can see, it will be much more stronger than polyethylene because उसमें सारे hydrocarbons हैं, non-polar हैं. So yeah, so polyamides समझ आ गए? Any question about polyamides? All right.
I have to say.
Allah Hafiz.